Today's lesson focuses on net ionic equations. In many ionic reactions, and when we say ionic reactions, we mean reactions specifically of single displacement and double displacement. So predominantly those two types of reactions that involve ionic compounds. Not all of the chemical species undergo a change. Okay, so what this means is that from reactant to product side, you actually don't have a chemical change occurring with some of the ions. Certainly you have a chemical change occurring with some of the ions because you produce either a gas or a new solid or a new liquid, but many of the ions actually don't change at all. The ones that do not change are actually called or given a name of spectator ions. Okay, so they hang out on the reactant side as an ion dissolved in solution, and then you'll see them again on the product side dissolved in solution. They are not part of an actual chemical change. So when chemists remove these spectator ions, and they will, because they kind of say to themselves, well, we don't need them, they're not doing anything, so let's just get rid of them out of the overall chemical equation, then what we have remaining is a net ionic equation. And that net ionic equation is only involving the ions in a chemical change. Okay, so they are the ions that are producing either precipitate, so a solid, or a liquid, or a gas. It says net ionic equations indicate only the substance that undergoes a change. Okay, that's it. So the change in state that will happen. And they are important to know because you'll see them a lot. So many times we'll simplify reactions down to a net ionic equation to remove these ions that don't do anything. So how do you go about writing out a net ionic equation? Well, there's 3 steps to it. And you already know the first step. So the first step is to balance the equation for atoms. And this is what you do every time you come up with a chemical reaction. Okay, so this is something this is not new. Okay, you guys are doing this all the time. You're just balancing your reaction and writing out your complete chemical equation. And then what you do, and this is why states are so important. Okay, we need to know the states of all of our substances. That anything that is dissolved, okay, and we know that if anything's dissolved, that means it's dissolved in water and that it is aqueous. So you are after the aqueous states. We will write out those dissolved species as they exist in solution, which is as ions. And anything that's not an aqueous state, so precipitates, which would be a solid, liquids, which would be L, gases, which is a G, are not written as ions because they're not ionic, right? They're bound together and they hang out as one molecule that is not dissolving itself into water. When you do this and you separate all the aqueous substances down into their ions, we call that a total ionic equation. And then we take a look at that entire reaction and we remove any common aqueous ions. These are the spectator ions. Okay, so we take out any ions that look exactly the same on reactant and product side, and then what we are left over with is our net ionic equation. So let's run through an example of a net ionic equation. So here's a reaction. It says a solution of barium chloride combines with a solution of sodium carbonate to form barium carbonate and a solution of sodium chloride. So stop the video and write out your balanced chemical equation right here and make sure that you include the states. When you're done, come back and keep playing the video. So what you should have is an overall chemical equation, and I'm going to put mine up here, of, my pen going, of barium chloride. And make sure again that you have the proper states and the proper formulas. Reacting with sodium carbonate, which is dissolved in solution. It's forming barium carbonate. This is your precipitate. And you know that from the solubility chart. And it's forming sodium chloride. which we all know salt dissolves in water. Do you need to balance this? Yep, you do. Okay, so you have to put a 2 in front of sodium chloride to balance those sodium and chlorine ions on the reactant side. Okay, so that's not new. You've done that before. Now, number 2, we're going to write the total ionic equation. So any aqueous substances, we're going to separate into their ions. Anything that is a solid, liquid, or gas, we leave it alone because it doesn't dissolve. Okay, so we don't write out ions because there aren't any that are free and moving around in water. So this is what we do, is we take a look here at our first substance, which is barium chloride. And I'm going to separate these two into their 2 ions. So I start with the barium ion, and you just have to go to the periodic table and look up its charge. So we know it's got a charge of +2, and we're going to write the state of aqueous. Then we move to the next ion, which is the chloride ion. So we write the chloride ion. We know the charge is -1 from the periodic table, but we have to be careful here because we see in this formula that there are 2 chloride ions. So to balance this, we have to put a coefficient of 2 out front. Remember, we never balance any kind of substance in a reaction by putting a subscript of 2 down here. Okay, it's always a coefficient. So you have to do that here. You move on to the next compound, which is sodium carbonate. And again, split your ions in 2. You got a polyatomic of carbonate and you got a sodium ion. We notice that my sodium ion has 2 atoms of it, or 2 ions. So balance it by putting a coefficient of 2 out front. And that sodium has a charge of +1 and is AQ. The next ion is the carbonate ion. There's only one of them, otherwise it would be bracketed. And it's got a charge of -2. You have to put in the states and the charges. You have to, okay? Because if you don't put a charge in, we think then that it's maybe the element sodium, or it would be carbon trioxide gas, okay? If you don't put a state in, or sorry, a charge in, you've got to be specific to that. We move over to the product side, and here we are with our product barium carbonate, but it is not AQ. So don't separate it. You leave it alone. This is your precipitate, and you would see this precipitate floating around in solution. It's not dissolved. We move over to the last substance. It is aqueous, and I have a 2 out front. The 2 applies to sodium ions, and the 2 applies to chloride ions. So we're going to separate those into their 2 ions. And again, that 2 applies to both. And then put your states in. Okay, so there's your total ionic equation. It's long, it takes some time to create. And then we start to look for spectator ions. So remember, spectator ions look the same from reactant to product side. So you look on the reactant side. Here's a barium ion, but on the product side, I don't see barium ion. It is bound with that carbonate. So that is not a spectator ion. Let's go to the next one. I have 2 chloride ions, and then over on the product side, there they are. I have 2 chloride ions. So I'm going to cross those out. Those are spectator ions. I'm going to get rid of them. They are not changing. Then I have 2 sodium ions, and I notice I have 2 sodium ions on the product side. Gone. Those are spectator ions. And then I notice I have carbonate ions, but I don't have ions on the other side. They are held or bound in that solid precipitate. So what's left over is my barium ion and my carbonate ion forming the solid barium carbonate. And what this does is this just shows the ions that are involved in the chemical change. Okay, the barium ions, carbonate ions are forming a precipitate. We know this from the solubility chart. We don't care about those other ions because they're not forming anything new. Let's look at one more example. So here's a reaction, a single displacement reaction, and it's saying write the total and the net ionic equations for the following reaction. So always make sure that your reaction is balanced. Those coefficients are very important. And I can see here that it is not. So I'm just going to call my pen up here, and I'm going to put a 2 in front of HCl to balance those chloride ions and those hydrogen ions on the product side. Then I'm going to write my total ionic equation. Okay, so we use this acronym TI, all right? And again, anything that is AQ, we're going to separate. So when I'm going along and I see zinc in the solid state, I'm not separating that or putting it as an ion because it's not. When I go to the next one, I have 2 hydrogen ions, 2 chloride ions because I have an aqueous solution. So we're going to write out 2 H+ ions that are dissolved in solution, and I have 2 chloride ions that are dissolved in solution. I move to the product side and I'm only separating anything that is aqueous. So right here, here's some zinc chloride, it's dissolved. So let's separate it into its 2 ions. So zinc has a charge of +2. And again, if you don't know how we got that, just go to the periodic table. It's listed there. And then I have chloride ion, but I have 2 of them. So remember, we have to balance with a coefficient of 2 out front. And then I have AQ. And then lastly, I have hydrogen, but hydrogen is a gas. That state's supposed to be over here. So we're leaving that alone, not separating that because it's not aqueous. What are your spectator ions? Well, this doesn't have as many spectator ions. The only ones that I see that are exactly the same from reactant to product side is your chloride ion. So we're going to separate those, or sorry, cross those out. And then that's it. Everything else is part of a chemical change. So we're going to write out zinc solid will react with some hydrogen ion. And it's going to form zinc ion, which will look different and has different states. And then we'll see some hydrogen gas being formed. And there is your reaction, and it is balanced, and it is reduced down without those spectator ions.